All right. Today we are going to learn about Django. And Django is the backend web framework that we're going to use to really start connecting all the puzzle pieces. We've learned about the front end. You've gotten a bit of a taste of writing a backend web server with Flask in the full stack week. We've learned about databases and Django is really how we're going to build our own APIs for our own full stack apps that our own front ends will use or consume. The agenda for today is I'm going to briefly do a high level overview of Django, and then I'll talk a little bit about what we'll be building. Um, we'll do a bit of a review of Python virtual environments because we've seen them, we've used them, we've loved them, but we haven't used them in a minute. Um, so we'll talk about those just a little bit, and we'll be using them a ton with Django. And then we'll actually install and create our Django project. As we're going to see, Django is very heavyweight. If to use the tool and construction metaphor, this is the giant crane we use to build the skyscraper. It's incredibly powerful, but it means there's more complexity in the setup. And we're going to see how to connect it to a database. And we've been playing with and learning about tables in Postgres. And we're going to see that Django gives us an object-oriented programming way to deal with tables in Postgres called a model. And we'll talk about that. And then we'll break and we'll have some hands-on work time. And part two, we will dive more into models because models, since as we will learn, are how Django talks to the database, are very much at the heart of things. Any questions before we dive in? Okay, cool. So I'm going to do a little bit of talking, a little bit of drawing, a little bit of slide decking, just to kind of set the stage, and then we'll dive into once we start talking about virtual environments, we'll really start writing code. So Django is a backend framework. It's built in Python, and you all remember working with Flask. I don't know if it feels like a million years ago, but we used it a little bit. And you were able to make the term is an API endpoint where your front end could send an HTTP request, right, over the internet and get a response back. So Django is that in spades. Um, and remind me, how much time have we spent talking about RESTful APIs? We've talked about it a little, but not a lot. Is that about right?
Yeah, I feel like we touched on it
Yeah,
before that full week stack a little bit, and that was kind of it.
yeah,
Yeah.
just barely.
We'll learn it more as we get into Django. I'll do a very brief overview of it today just to help again set the stage. Django's popular because it's what's called batteries included. And here think Bootstrap versus say Tailwind, right? If Flask is maybe a bit more like Tailwind, it's very lightweight. Django is very much Bootstrap. Django, right? It's got everything but the kitchen sink, which again makes it incredibly powerful, but does make it more heavyweight. And when we're using Django, we really have to do stuff the Django way. And you're going to spend tons of time with the Django docs, which they're good. They're not amazing, but they're good. But Django is incredibly powerful. And also, it's what's called a model view controller architecture. Though Django, we don't really have a controller in the same way, but this is a term that you'll see. And as we get into it, you'll see what this means. And there's many other frameworks that are similar. Um, Similar frameworks in other languages. Um, .NET, for C Sharp, which is Microsoft's language, Laravel for PHP, Ruby on Rails for Ruby, um, Spring Boot, I think it's called, or Java. And those are really the main ones. There's also Express or Node.js. This one is kind of different. But point being, these are all also OOP languages. So once you learn Django, when you step into at some point in your career, you'll almost definitely work with another language. Possibly even for your first job, they'll want you to kind of learn it and they'll hire you knowing you have the ability to learn that and skill up. And you'll find that the same patterns that we're going to learn over the next 2 weeks in Django are in these other frameworks as well. Um, let's see. We'll come back to virtual environments in a minute. Let me just do a little bit more talking and let's take a quick kind of big picture look at what Django does for us here. And let's get rid of this because we don't really need it yet. Well, we're going to need it later, so I'll leave it up. So to kind of like step back, let's look at our web app, right? And we've got the browser. And as Francisco loves to say, everything is boxes within boxes. And within the browser, we've got our React app. And we want to get some data from the Pokey API. And so the browser might send an HTTP request. And remember the different kinds of HTTP verbs. I know we've talked about this a little, but not a lot.
You're talking about like pull push requests,
Not pull push,
or are you talking CRUD?
CRUD.
Okay.
Like if I wanted to create a new Pokemon instead of a GET request, what kind of HTTP request would this be?
Post.
Post. Yeah, exactly. Um, so there's really, and I'll show you all, we'll do a deeper dive into HTTP requests as we get into Django because we will be building our own API. If you want to, what you can in fact do is open up the network tab just and have it open while you peruse the internet. If I go here to network, and in fact, let's go ahead and clear all this junk out of the way. And for instance, what I see here is every time I type Wikipedia, and this is undoubtedly some JavaScript running in my browser that Wikipedia is loaded for me, is making an HTTP request. And we can see here the URL. I can see here the request method, what's also called the verb, the status code of the HTTP response, the payload shows me, I can see this is the query string is what's called all the stuff in the URL bar here. And in fact, let me add our toolbar so we can see it. Response shows me the HTTP response sent back, and this should look familiar, right? From working with the Pokey API, we can see that we have some metadata, how many pages there are, and we can kind of see that as I'm searching for, right, cats, all of the data needed to do this is in this HTTP response in this most recent one, a thumbnail image, information about how big the image asset is, and so on. And we could imagine if we were building a React app, we could build this, right? We could work with this. But the ticket to getting all the data is the HTTP request, right? And an HTTP request is just text. We'll learn about it later, and we can actually make HTTP requests from the command line. And there's just conventions and rules around the different request verbs or methods. And the convention is that get is to get data. Post is when I want to say create data in a database, like if I'm saving a favorite Pokemon or changing my user profile information. Put is to modify and delete is to delete. And in fact, if we wanted, we could stick this URL in the browser and it would get that same data, though this isn't very useful to view it in the browser, right? So I do recommend just have the network tab open while you browse around the internet. Start looking at this just to get familiar with it. This is probably a good starting point is this article on REST if you want to get into it more, or maybe introduction to web APIs. But we'll talk about this more later. Today we're going to focus on Django, but the reason I did want to touch on this, and I'm going to use the word server to refer to Django and the database and everything else. Um, and Tim, like you were saying, um, there's another acronym, CRUD, that talks about if I'm building an API, an interface for a client like a React app, or maybe it's a mobile app, or maybe it's just the browser, or maybe it's even a desktop app to interact with my backend server through HTTP requests. There's very common things we want to be able to do, right? Create, read, update, delete. And again, if you think about like building the Poke API, but maybe we wanted to make it fancier so that administrative users could add new Pokemon and stuff, then you could imagine we would also want to be able to, create a new Pokemon and modify existing Pokemon and maybe even delete them. And we'll talk about sort of REST APIs and what that acronym stands for later. But basically, what all of this is just conventions and rules of the road. The same way that when you drive on the right side of the road in the US, you're following the rules. In Britain, you drive on the left side. When you stop at a stop sign, there's a rule of the road about who goes first. If everyone stops at the same time, it's the person to the right. A yellow traffic light means to slow down and so on. And just like with the rules of the road, I can break them if I want. There's nothing in like the technology itself that kind of forces us to use HTTP requests this way, but pretty much all the programs you write and interact with on the internet and will do in your career follow this sort of design pattern. So both to work well with other systems, so other programmers can use your code, and also so you're following industry best practices like you'll be doing in your first job. This stuff is valuable to learn. And so let's change this actually from post to get, because this is a simpler one to talk about. We've got a browser. And actually, before I move on, I just want to check in to see if folks have any questions, because I know I did do a lot of talking there, and some of this we've touched on, but some of this is a preview of what we'll be going into more later. How are we feeling thus far? Awesome. So we've got this kind of context that our world communicates in HTTP requests. And our React app from the browser sends a GET request over to our server because we want data about our Pokemon. Um, and I'm going to make the Django server just a bit bigger. And we're also going to need a database. And I'll make my database an oval because you kind of traditionally represent databases with a cylinder. And somewhere in our database is a Pokemon table. The same way that we've been learning to make for the last week. And as we'll see today, Django will actually do the work of creating this table for us, and it will do the work of writing the SQL, but we'll get there in a minute. We're not going to talk yet about the code inside Django that does the work, but Django is going to talk to our database, and it's going to, say something like select star from Pokemon where ID equals 3. Though, as we're going to learn today, we don't have to write this SQL. We're actually going to be able to use Python OOP code, and Django will generate the SQL. And Django gets the data and sends it back, right, in an HTTP response. And let's just pretend that, the Pokemon with ID 3 is Pikachu. And then we can show Pikachu in our React app. So I know some of this is review, but this is just a really high level overview of our system, right? Because it now actually has 3 different parts. And in fact, each of these could be running on a different computer. When we deploy our system to production, when we make our Pokemon API live for real, just like with the Poke API, my browser is running on a different computer than the Poke API server, and these HTTP requests happen over the internet. The Poke API server could be written in Django. The beauty, by the way, of HTTP requests and this sort of REST API pattern is my React app, my client doesn't have to care how the server works. The server's job is to serve the client, and the Poke API could be written with Django, it could be written with Flask, it could be written with Java, it could be my grandmother handwriting letters and, squirrels running on treadmills. It doesn't matter, right? All that the client needs to do is be able to send an HTTP request and get an HTTP response back. And it doesn't have to know or care about SQL or Postgres or anything else. And that's the beauty of this abstraction. For what we're doing over the next 2 weeks, and let me get our diagram back. There we go. For what we're doing over the next 2 weeks, all 3 parts of our system are running on the same computer, right? These are all going to be running on my laptop, but it's important to remember in the back of your head that the reason all this stuff is designed this way is because when we're, oh man, I don't know how to hide it. That's okay. When we deploy this live over the internet, our Django server might be running on one virtual machine in the cloud. Our Postgres database might be running on another one, and then the user's browser is, wherever the user is. And so this is really a distributed system, a simple distributed system with the client server architecture. And I just want to check in if folks have any questions before we move on to talking about Python virtual environments. How are we feeling?
So for the like the Django server, it's basically going to be using like converting whatever Python like model you create into an SQL query.
Yeah, we're going to see that later this morning. Django will do all of that work for us. We're not going to write any SQL ourselves. That said, when you're debugging stuff, you will probably need to go into pSQL sometimes to look at the data in the database. And in order to understand how Django is doing what it does, it's really important to understand Postgres and SQL. And that was really the goal of last week for us. Plus, SQL is good to know on its own. Maybe one day you need to generate some reports from a database with it. It's just a useful tool. Yeah, that's a great question, Chase. And did that help answer your question? Any other questions, things on people's minds? Awesome. Let's talk about virtual environments. So we haven't looked at these in a minute, but um, a virtual environment, right? It's a container that we use to put all of our dependencies in the stuff that we're going to install. So when we install Django, it's going in a Python virtual environment. Um, any other Python library we need goes in a virtual environment, a Python virtual environment. What's the equivalent of a Python virtual environment for React and JavaScript and the front end? They don't work the same way, but what does a similar job?
Wouldn't that be
The
Bootstrap?
Not Bootstrap, not the router. Think
Yeah,
about
NPM.
NPM. Right. When I install Bootstrap, where does it go?
It goes in the npm.
Yeah, exactly. It goes in that node modules directory, right? And we've got that packages.json directory that keeps track of stuff. And the package.json file and that package lock.json file and npm, that's like our dependency management tool. When we need to install libraries that we're going to use that our project depends on, we use npm, and package.json and node modules handles it. And in Python, we use a Python virtual environment. So, trick question: does a Python virtual environment have anything to do with a virtual machine?
No.
Correct. They do not. I strongly believe one of the worst named things ever is the Python virtual environment. I'll show you where this term comes from, but it has nothing to do with a virtual machine, and it's not that fancy. Excuse me. Python virtual environments won't affect JavaScript code or anything else. It only affects our Python. Let me go ahead and just start working with one. Oh, excuse me. And I'm totally sneezing over here. So let me give us a little room to work with, and let's start doing a little work with Python virtual environments. So can someone remind me how I create a Python virtual environment? It's been a minute.
Python dash M
Yep,
VNV and then the name
yep,
dot VNV.
yep, exactly. Anyone know what this -m flag does, more or less? So it stands for module, and it lets us run a Python module, aka say some Python file, aka a Python program, um, from the command line, in essence. I think there's a bit more. In fact, we can ask the internet. In fact, let's do one better. Let's just ask ChatGPT real quick. And we'll give it a minute to do its thing, and then we'll get a much better answer that probably covers some of my hand waving. And it looks like ChatGPT. There we go. So, yeah, long story short, if we have a Python program and we run it directly from the command line, and it might not be quite written that way, Python dash M lets us do that. And so the module we're running is named VENV, virtual environment, and I believe it got installed when we installed Python. And this is the name of my virtual environment directory. I do recommend just naming all your virtual environment directories .venv, VS Code will pick up on it. And now this .venv virtual environment directory has been created. Let's explore a little bit of what happens inside here. If I go inside the lib directory, I actually see pip is installed inside here. It's a little hard to see, but Python version 3.3 is actually installed inside here. Inside this bin, short for binary directory, I see some things I can execute, including a shell script, which is what we run to activate the virtual environment. And this is a bunch of bash stuff. We don't really have to worry about what it's doing, but it does modify the bash path. And that's kind of the only magical thing of the Python virtual environment. So once I've created a virtual environment, the next step is I use the command line command source, which is how I run a bash shell script from the command line. Bash is the mini programming language of the command line. And I give it the path to that activate script, right? And now my command line prompt has changed to show me the virtual environment is activated. I can run this command that's been loaded, deactivate, to deactivate it. And let me briefly talk about what this does, because I think it'll help understand a bit what's going on. This shell variable path, every time you start a shell session, a bunch of environment variables for that shell environment, for our command line environment, get created. The name of the shell is one of them. Echo is our command line print statement. The $ is how we tell the command line we're dealing with a shell variable. They're all uppercase by default. Path is kind of special because whenever you run something on the command line, this is how the command line, how Linux or OS X finds stuff. And note we've got these directories, adamc/bin/user/local/bin. For those on Mac using Homebrew to install stuff, opt homebrew bin, right? Like if you look at this, you're like, oh, yes, I think I've installed something there. And when I type which Python 3, the way that the which command works is it looks at that path environment variable to find the directory that Python lives in. When I activate my virtual environment, and now let's look at this path, what we see, it's a little hard to see because it's a very long file name, but here, like the very first thing that is now in the path variable is in fact that virtual environment directory, and specifically the /bin directory. So now anytime I do anything Python-y, it looks here first in this virtual environment directory. So virtual environment just means we're tweaking the shell environment that this runs in. It's kind of a overly fancy term. And if I go ahead and install Django, Django and some other Python modules that Django depends on will get installed. If I look here inside libs, short for library, right, in my virtual environment directory, because I activated it, pip knew to install stuff in here, and I see Django has been installed along with some other modules that Django depends on. I might as well upgrade pip. It often has new versions, as you can see here. There's a little message for it, and it won't hurt to do it, and it shouldn't take more than a minute. And in fact, I see in my virtual environment directory that new version of pip, version 25, has been installed. And now when I've got this virtual environment activated, I'll be using the newer version of pip. Now, if I do the command pip freeze, it prints out to the command line all the dependencies I've installed using this Python virtual environment and their specific versions. And a common convention is to pipe the output of this command into a file named requirements.txt. And I think this should ring a bell. We haven't done this in a minute, but we did it at some point. Is this ringing a bell or two? Yeah. And just like how for a JavaScript React project, we had package.json that was our dependency file, we now have requirements.txt because I don't want to check the virtual environment directory into version control. In fact, I'll make a git ignore file so that when I do git commit, it ignores this. Because it's a lot of stuff to check in, and the important information for other programmers is actually the specific version of each dependency. And so I only need to check my dependency file into version control. And that's what gets pushed up to GitHub. And then when you want to work on my project, you can clone it down. And for those of you that saw the issue with the SQL assessment tests, like we had Postgres, but we didn't have Postgres version 14. And so it kind of, when we installed it, went from 14 to 15, and that caused some issues. So we won't need to get into the weeds with virtual environments. Really, the main commands we'll need to do are creating a virtual environment, activating it, deactivating it, installing stuff, and creating a requirements.txt file. But I wanted to walk through it a bit to hopefully like demystify a bit what it does. And that's also, by the way, where like it doesn't matter what directory I'm in, because the virtual environment tweaks that path shell script variable. No matter what directory I'm in, as long as the virtual environment is active, we're going to be using the version of Python and all the different dependencies we've installed in there. Right. And I can deactivate the virtual environment from anywhere. And now I'm using a different version of Python. So I just want to check in and see if folks have questions or there's anything that you all are curious about with this before we keep on rolling.
Do you want us to
Go ahead,
go
Tim.
Do you want us to create a new virtual environment for Django compared to we've been using the default one we set up a long time ago.
Yeah, good practice is to create one per project. Um, you can use the default one. Um, I think it's a good idea to start doing it per project. If that feels like it's going to be a massive pain point, you can keep using the default one for a while, but at some point you'll have to switch to per project. And what I recommend doing is just in the root directory of each project, you create a virtual environment directory. It also has the benefit of consistency, right? Every single Python project you work with, you do the same process with the virtual environment. That's also how VS Code will kind of automatically pick up on like what Python interpreter is being used and like the dependency files, so you don't get the red squigglies when you import stuff. That works just fine. So I do recommend one virtual environment directory per project. I do recommend naming it .venv and putting it in the project root directory.
All right, thank you.
Yeah, great question. Great question.
So in that case, when we're activating a virtual environment, after we create it in the project, we'll have to open it from that root directory folder. So it knows, so because we have a whole bunch of different projects with the virtual environment called v.venv.
Right.
I mean, we wouldn't want to be
Right.
confused, so we'd have to open it from the project root directory for the virtual environment we care
I mean,
about.
you don't have to. Right here, I'm a level up from where the virtual environment is. I could do source one dot then bin activate because I can pass the path to that file and run it from anywhere. That this works totally fine, and it is good to get comfortable doing that on the command line. Everyone kind of see what's going on over here. That said, for your own sanity and consistency, what I like to do is I make sure that like one of my terminal sessions is always in the root directory of the project and then run all those commands from there, and it makes life simpler. And then like you're saying, Jason, you would do it exactly that way.
Yeah, so I just I don't feel like there's confusion between which virtual environment I'm opening in different
Yeah.
projects.
Yeah, that's a good point. Yeah, and I think that makes it easier. Like the key thing is get yourself sort of oriented on the command line so you're in the project root directory. And I think having this open can help. You can right click and you can do open an integrated terminal, and that will open a new terminal window in whatever directory of the file is that you right clicked on. So actually that one was a level too far. I wouldn't want it there. I should. So if you right click on your README, you know, open an integrated terminal, then you can always get yourself home to your project root directory. Cool. Why don't we take 5 and then we'll install Django and look at Django. Sound good? Awesome. Thank you, everyone, and I'll see you all in 5 minutes. All right. So we've sort of done the high level overview of Django, right? We talked a bit about HTTP requests. We've done a deeper dive into Python virtual environments, um, the .venv directory. Um, and I can also do pip install, I think it's r requirements.txt, and it will install everything in the requirements.txt file. Now let's create a Django project, and then we'll see how to configure it with Postgres. And then finally, we'll see how to actually start creating, instead of tables, we'll be creating what's called models. So let's go ahead and make some Django. I already installed Django. My virtual environment is activated, right? My virtual environment, well, I don't want it sort of activated twice. My virtual environment is activated. My sanity is restored. I've installed Django already. Now we can use this command on the command line that gets installed when Django is installed, called Django admin. And as you can see, Django admin has a lot of different commands. We're not going to have to worry about too many of these right now. The main ones we're going to focus on are start project and start app. And let's use Django admin help real quick to look at start projects. And this is a pretty dense, uh, manual file to read of this. To be honest, it's probably easier to Google this to really understand what it does. But if you're doing stuff on the command line and you maybe need a quick reminder of something specific, this can be a useful tool. But to start a project, we're going to do Django admin start project Pokédex project. And that's the name of my project. And as we can see, what's happened is it's created a directory in here. And we'll dig into all of this stuff that's been created in a minute. But let me go ahead and delete that project real quick. If instead of putting the project in a new directory, I wanted it in the same directory, I could do Django admin start project, Pokédex project, and a dot for the current directory. And it's a little hard to see because there's this sort of nested directory structure that gets created. But here, this manage.py file is on the outside. And let me go ahead and just delete that and delete Pokédex project. And if we want to, we can also create a project by using Python-M to run the Django module and give it the start project command. And I could do the same thing with or without a dot. And let's go ahead and create a project that way.
I have a question about I'm seeing a git ignore. I mean,
Oh yeah.
so so it's empty. We have requirements .txt, which I'm confused. Never mind.
Yeah. No, you're good to go. Git ignore when I commit something, whatever directory or file name or sort of like pattern, like every file starting that has like the .foo file extension, Git will ignore it when I commit. So this will ignore the virtual environment directory.
So why do we also need requirements .txt?
Yeah, because the virtual environment directory has like all the actual dependencies in here, like Django is installed in here, and so on. I don't actually want to commit this to my Git repo and push it up to GitHub. It takes up a lot of space. There's also other reasons that are a little outside of scope that I don't want to get into right now. So we want Git to ignore this. But what I do want is a good list of the stuff that needs to be installed. And this does get checked into version control with Git and pushed up. So when you clone my project, you can run pip install that -r requirements.txt, and that will install the exact versions of all of the requirements into like your virtual environment on your computer for your for this project.
Okay, thanks.
Yeah, great question. Great question. Let's take a look at this Django project because there's a lot of directories that are created here. First off, we can see that there's a Pokédex project directory, and I named it wrong. So let's just delete it. And let's rerun my command. And let's spell it right. There we go. So there's the Django project directory, and there's this file manage.py. We will never modify this file. We will sometimes run this Python program from the command line. As this comment says here, this is Django's command line utility for administrative tasks. Right? And Django is going to have, it generates tons of code for us. So it's important to start thinking about the files we do touch and the files we don't touch in Django. And this is one of the files we don't touch. You should never have to be modifying manage.py. Inside the project directory, there's this dunder init.py so that this sort of works the right way as a Django module. We'll never need to touch that. ASGI is sort of like an older way of servers kind of talking that I know a little bit, but not a lot about, to be honest. And we don't really have to worry about it. And we're not going to touch this file ever either. Settings.py is important. We'll learn more about this later. Think of this as the control center. Like when you go into your car and you turn your car on, you know, is the turn signal on or off? Is the radio on? These are all sorts of settings. And it's really important to not touch anything here that you don't know what you're doing with or you're not supposed to, because this configures everything for Django. We're going to talk about Django apps in a minute. Everything in Django is inside an app to help organize things. And we can see here there's a lot of built-in Django apps for an admin page, for authentication, for dealing with static files like image files. Middleware we'll learn about later. And we can see these are lists of strings, right? But these are actual Django module names. And we can see here there's stuff related to security and authentication. And we'll learn about this later. URL configuration we'll learn about later. Templates is sort of an old school way of actually generating HTML before things like React.js existed. We're not using them at all because our front end is React and Django's job is just to be a REST API.
So
Databases,
does that
yes,
mean we just leave this alone, or could we delete this stuff, or should we delete this stuff?
yeah, good question. Leave it all alone. Don't delete anything. Um, as you work with more complex tools, the rule is always when in doubt, don't touch it. And that's not just for Django. And I know it sounds a little silly, but you'd be shocked at how challenging a rule it can be to follow. Um, all this stuff can be left. Like, even though we're not using templates, Django will probably break without these configuration settings. Um, Databases looks a little more up our alley. And indeed, as we create our database, we will be changing this. Note that the database engine is a database called SQLite. We'll actually be changing this to Postgres in a little bit. And then here, the rest of this, you can see things that we're not going to worry about. You can deal with multiple languages, time zones, stuff like that here. Where do static files like CSS and JavaScript go? We don't need to worry about this because we've got React, though with image assets, maybe. So there's a lot of stuff in here, right? And the main thing again is today and tomorrow, we're really only going to have to mess around with this databases bit in here. And everything else, as a general rule, should stay untouched. URLs PY, we'll learn about more tomorrow. Or maybe not tomorrow, but over the next several days. And if I can find my page. There we go. But URLs PY is where we'll set up the URLs that HTTP requests come from. WSGI is also a file that we just don't touch, that just has some configuration stuff. We'll be adding and creating more files as we go. And in fact, the next thing that will be created. So as you can see, the Django project structure is big, right? The database is sort of off to the side, but we have a project directory. For us, it's named Pokédex project. Everything in Django is inside an app. And you can think of an app as a container, and it's good to follow the single responsibility principle. You can think of it sort of as like containers of ice cream in a freezer. If the project is the freezer, like the different flavors of ice cream are each a different app. Today and probably tomorrow, we just need one app. As stuff goes on, they'll get a bit bigger, right? And so the project is the freezer, but then all the good stuff is in the individual containers. So right now, this is pretty similar to what our project directory structure looks like. And in fact, in a moment, I'll hop back to VS Code and we can look at it. And you can sort of see the commands here that we did. We created our virtual environment. And let me point these out. We created our virtual environment. We activated it. We upgraded pip. We installed Django. We started a project. And now we're going to start an app using that manage py file. So let me clear the Zoom annotator. My apologies.
I guess I do have a question.
Yeah.
With like the .vnv files, or can you name those like pre the dot?
You can name them anything you want. Naming them .venv is more of a convention. And I do recommend doing it because VS Code will actually look in the root directory of whatever directory you open for .venv files. And it makes things like select Python interpreter easier Like right here, we can see that it was a little hard to see, but the first option was the .venv directory in the current file. Also, that's sort of the convention. That way other people like it's just a good habit to follow. Because that way, whenever you see a directory name .venv, you know exactly what it is. No matter what project you create that you're working in, you know the name of your virtual environment directory. And it doesn't really need a special name because what matters is the directory that we put it in, right? And that's kind of what makes it unique. Does that
Gotcha. Yeah.
Yeah, good question. So let's go ahead, let's make a Django app. I'm going to use the manage py command and the start app command, and we're going to name our app Pokemon app. Putting underscore app in the name is just a convention. I do recommend doing it because the Django directory structure can get a bit dense, and it's really nice because now it's easy to see this is sort of the main project file, and the app one. Let's see, I probably should have created it inside of it, actually. Let's go into the Pokédex project directory and create it there. Oh, and it doesn't like it because I can't. So I think our diagram, in fact, may be a little off. But this way, at least we can see the different directories a bit more easily. And now there's a bunch of stuff here inside this app directory, right? Some of this I'm going to skip over. init.py, admin.py, we never need to touch. Apps.py, we never need to touch. This is how Django configures itself. Models.py, we will be dealing with today. Tests and views, we're not going to worry about. So now that I've created this app, I actually do need to start changing some of my Django settings. And I need to go up here to installed apps. And I need to add the name of the app that I created so that Django knows to find it and use it when we're running Django. We should also set up a database. Let's make a database, and I'll just do this from the command line with the create DB command. For simplicity, try to keep the database names similar to your Django projects. And I already have one from, teaching this a while ago. So let's just drop that database. Excuse me, drop DB, Pokédex DB. And now we can do create DB, Pokédex DB, and we can have a nice, clean, empty database. And now that I've done that, I need to tell Django to use that database. And so I need to make two changes here. I need to tell Django to use Postgres. And I need to tell Django the name of the database, which does not have to have all that clever stuff. It can just be Pokédex DB.
I have a really quick question
Yeah.
regarding. So when you do the drop DB and you drop that database, did it drop it only in like your current virtual environment and not the other ones?
Great question. That actually has nothing to do with the Python virtual environment and everything to do with Postgres and PSQL. Right? If I let's see, L, there we go. The L command lists all of my databases, and somewhere in here is the Pokédex DB. There we go. It's hiding there, but if you all can see me highlighting it, Pokédex DB that I created. And the same way I could do inside PSQL drop database Pokédex DB, and that database would be deleted in Postgres. When we installed Postgres, it installed some command line utilities, create DB and drop DB, that do the same thing. So now if I hop back here to pSQL to look at my Postgres, and I do /L again, we see the Pokédex DB over here is back. So it's a little confusing because it's from the command line, but those were actually command line utilities for doing stuff with pSQL and Postgres. Does that make sense?
Thank you.
For sure.
Yeah.
To be honest, what might be easier, what I like to do is I always have pSQL, open in another terminal session. And if it's easier to keep track, you could just run everything database related from here, right? And do your create and drop commands in pSQL with SQL commands rather than from the command line. I think that's really a dealer's choice. To use Postgres with Django, we do need to install a library called psychopg2 or psychopg3, excuse me, which is how Django and Postgres will talk to each other. And this is what lets Django and Postgres talk to each other in essence. And we need to install it with a slightly different looking command because the name is not psychopg3. We need to pip install. And all this, by the way, is in the curriculum README for today. And that's by far the easiest way to go through this stuff will just be to pull that up and run through it step by step. Pip install psychopg, and we need to install the executable file, the binary. So it's a little annoying, but we have to install it like this. Oh, and at some point, I lost. Yeah, let's just kill that terminal so I don't get confused again. Since the virtual environment is specific to a shell session, I was in the wrong one. So now let's do pip install psychopg binary. And let's do pip freeze and update our requirements.txt. So requirements.txt now has our new dependency in there. And finally, let's run Django more as a sanity check to make sure that I haven't done anything silly. It's not going to do much, but hopefully it'll run. So good news, nothing is broken. Oh, I did forget migrations. We are going to do and talk about migrations in a minute. So even though the Django server is running, when I go to this URL, we may not see anything because we haven't talked about migrations. So that's good, actually. So this is my Django server. This web page we're seeing is buried somewhere in one of the built-in Django modules that gets installed. It might be admin or somewhere else. So this is just sort of a default message. And in fact, it tells us we're seeing this page because debug equals true is in your settings file, which is indeed here, right? So when we deploy to production to the live site on the internet, we'll set debug probably to false. And we haven't configured any URLs, but we've got Django up and running. Let's talk about models and migrations. So how does Django talk to Postgres? It does so with classes called models. And instead of creating tables, I create models. And this takes us back to OOP. And let's go to this models py file. Note that we're importing a class from the Django.db module. Let's see how to use it to make our first model. And this is going to warm up our OOP brains. It's a class. It's going to be named Pokemon, and it has to inherit from this models.model class. And we're not going to need to spend too much time in the docs today, though you will as time goes on. As the Django docs say, a model is the single definitive source of information about your data. It contains the essential fields and behavior of the data you're storing. Generally, each model maps to a single database table. Each model is a Python class that inherits from the main model class. Each attribute of the model represents a database field or column, right? And then Django will generate and create the tables and do all of the SQL querying. And it gives us not a REST API, but a different kind of API. And you can see here an example with a person where this is the code that we would write. And we're about to do something very similar for a Pokemon where we have a class. Each of these would be a column on the person table, but we're calling them fields. So these are actually attributes, the same way we might make a class attribute with a normal OOP class. Like class foo, and I could do, hello equals hello and goodbye equals false. And this is going way back, right, to OOP, but these are class attributes. We're actually doing the same thing here, but Django is doing a whole bunch of fanciness because this is creating a new instance of a char field, of a character field. And so we have a first name and a last name. And then we'll see this with migrations in a minute, but Django essentially generates some SQL that looks along these lines to create this table. So let me show this in action. And I think we'll go back here to kind of leave that off to the side. Let's build up our Pokemon model, and then we will actually create it in the database. So our Pokemon needs a name. And just like we can with the varchar field, we're going to give it a max length. And our Pokemon needs a level, like how strong is the Pokemon? Level 1, level 2, and so on.
Is 255 a significant number? Because I realize like we use it a lot.
Yep, it is. 256 characters is a power of 2. And 0 to 255, if you include 0, then 255 is your max. It's like 2 to the, I don't know, 5th or 6th or something like that. Because we got what, like 248, 16, 32, 64, 128, 256, 512, 1024, right? 2048. Those numbers probably sound familiar to everyone because everything with computers is powers of 2 because they're using binary. Yeah, great question. And then since we start with 0, we do 255. Does that make sense? Yeah, great question. Love it. Let me finish this off because I do want to make sure I take us home on this and that we have enough time to get our hands on this before part 2 of the lecture. So let me finish this off and then I'll pause for questions. Sound good? The questions are awesome. I just want to make sure that I don't eat too much into the work time. So right now I've created a model class This does not exist in the database. And this is where it is nice to have two terminal sessions where you can have pSQL and another one. And let's connect to our Pokemon, I think it's called Pokemon DB. I must have called it Pokédex DB. There we go. And there's no tables right now in the Pokédex DB. So what's going to happen is we're going to run in a minute a command from the command line, Python manage py, make migrations. This will actually use our Django code to create a bunch of tables in Postgres. Or excuse me, there's actually really two commands. Make migrations doesn't do that yet. The migrate command does. So let's talk about migrations, because this is a really important concept. And the context here is, imagine we've built our Pokédex API and it's live and we've got tons of users and it's doing great. But a bunch of things have changed and the whole server crashes. How do I rebuild my database to be exactly the same? Or imagine we make a mistake and we screw up the Pokemon table and I want to undo a very specific change I made to my Pokemon table. So the same way that Git and GitHub is version control for our source code, migrations is version control for our database schema. It lets us make tiny specific changes to our data model and undo them and go back, or add more and make sure that we build the exact same data model every time. So there's not a lot in this migrations directory at the moment. By the way, you'll see these PyCache directories that get generated. These should be ignored. You probably want to put them in a git ignore. If I go here, and let me go ahead and clear this. And in fact, let's do this in two steps. So let's make a Pokemon with just the name field. And let me run this make migrations command. I've created a file in this migrations directory, 001 underscore initial py. So rule number one of migrations, never modify the migrations file. Let me say that again. Never modify this file directly. I can guarantee you from experience, if you are, something has gone wrong and you want an instructor to be helping you. Every now and then you have to, but that's because something has gone really wrong. Migration files depend on other migration files and it gets extremely messy very fast. So if at any point you think you need to be modifying a migration file, that's when you need to go tap me or Francisco on the shoulder. Django generates these files and it's Django's job to manage them, right? What belongs to Django belongs to Django. And we can see here there's a class. There's this migrate create model command. It's a Pokemon, and then we've got some fields. It's added an ID field for us. When we make models, we don't have to make an ID column manually like we did with SQL last week. Django will just do that by default. I can see it's a primary key. I can infer that it's auto incrementing. And then I see here name as a char field. And so when I run the migrate command later, Django will actually use this to create SQL. And so in fact, let me go ahead and run Python. Yeah.
You said it's auto incrementing, but it says serialize equals false.
Yeah, I don't know exactly what that does. I don't know if it's using something other than a serializer. I just know that it's auto incrementing. I'm like 99% sure on this. The fact that it's named Big Auto Field, I think, is a bit of a key. There's other ways to do auto incrementing in Postgres, and also it could be that Django maybe is managing the auto incrementing. I'm honestly not sure. Hopefully I don't have to eat my words about the ID column being auto incrementing, but I'm like 99% sure.
Okay.
Yeah, that is a good question though. As with all things Django, if you look up in the Django docs, this model class, you'll find very comprehensive docs like breaking down exactly what each of these does. So we're going to use manage py, which is sort of like our control panel for configuring Django. And we're going to run the migrate command. Now, let's take a quick look at this. This tells us all of the migrations that were run. There, you can sort of get a preview of this, which I'll show maybe later today or tomorrow. Note all of these migrations that have nothing to do with our code. This is all default Django setup from, if I go to like settings py and you look at all those other apps, this is stuff from the Django admin app, from Django auth, and from other things. So we always need to run the migrate command with the new Django project. And then finally, all the way down here, we see this Pokemon app initial. That's our Pokemon model. And now if I go to pSQL and I do /d, all of a sudden, look at all these tables. Now, we don't need to worry about the default tables that Django creates. We really don't want to touch them. Django will manage them. But we can see here, we've got our Pokemon app table, and there's this sort of like ID sequence because we have an ID. And if I do DT to look at our Pokemon app, Pokemon, then I think it's just D. And note how Django names tables, by the way, right? It's the app name and then the table name. And here I can see the information about the table. And Tim, I think they're using an identity instead of serial under the hood with Postgres, to go back to your question. And we've
Thank you.
got a column and we've got the Pokemon name. The other rule with Django is you don't want to modify SQL directly 99% of the time, because Django models do a lot of stuff for us. Let's add another field to our Pokemon model so we can learn more about migrations. So I've changed my code, and this is the workflow. You'll modify a model, you'll create the migration, and this has added a new migration. And if I look here, again, we're never going to touch this migrations file. So don't worry too much about locking down exactly what everything here is doing. I more want to show you how the pieces connect. But we can see here that Django knows that this change to the Pokemon model depends on the previous one, and we're adding the new field. Now, the change has not happened to the database yet, because the workflow is modify the code, create the migration, and the term is apply. We now apply our migration to the database. And you could think about how if we had a live server in production and we had to undo a very specific database change or roll back to a previous version because of a mistake, how a migration tool could be really, really useful, right? And that's the reason why this exists. And also, it's even good for development because it lets us create exactly the same database schema every time. And now if I go here, we see that the Pokemon name has been added, right? So this feels like a lot, but it gives us a lot of consistency and control, and we don't have to write SQL directly. Models are a bit tricky because we kind of have to think about OOP and kind of translate it into tables, but they're incredibly powerful. So I've been doing a lot of talking, and I think now is a good time to pause for questions and see what questions folks have. What's on your mind? What might be good to dig into?
So is each Python or Django class gonna like translate to a SQL table?
Exactly. And in fact,
And do
yeah,
oh,
no,
do
no,
the
no, go ahead.
names of the class like attributes have to be the exact same as the table attributes?
Great question. Django does that for us. Django will name the table columns and it will name them the same as these.
Okay, makes sense. Thank you.
Yeah, totally. Again, you can see what Django does. The table name is the Django app name, and then the model name, and then the table columns are the names of our fields here. So, but just like how with React, we don't modify the DOM directly anymore, with Django models, and this is what's called an object relationship mapper or ORM. And you see them in all different OOP languages, right? We don't touch the SQL directly like 90% of the time, 99% of the time, really. We write OOP code, we write objects, and then Django maps those objects to tables and manages the relationships. And we're going to talk about relationships between different models or tables later. But just to show like an example, let's make another class. We'll call it moves. Because I think Pokemon have moves, right? This I'm a little ignorant on this. And do Pokemon new moves have a name? Am I thinking about this
Yeah,
correctly?
they have a name.
Yeah. And I'll just put as a to-do like connect a Pokemon to a move. We're not going to worry about that right now. But just so we can see another model created, I've written my model code. Once that's done, I run the make migration command with manage py. It creates a new migration, and we can see here, and you're never going to have to modify this. And then I apply the migration to the database because that move table does not exist yet. The migration file has been created, but we haven't changed our Postgres database. Now I apply the new migration, and it's perfectly safe. You can run migrate till the cows come home, and it doesn't break anything. Same with make migrations. That's the beauty of this. Like Django will kind of keep track of what needs to be created and what doesn't. So if I haven't modified this, then I'm good to go. And then by the way, if I like delete something, all I need to do is run make migrations, and there's now a new migration to remove the move field. If I change my mind and I want to bring it back, I can run make migrations again. We now have another migration to bring it back. And now when I run Python manage py migrate, it all gets handled nicely and consistently. And when I go to my tables, if I spell Pokemon right, I've still got the level there. And as you can see, we now also have the moves table as well. And I was playing around with the level field. I apologize, I got the name wrong. Yeah, great question, Chase. What other questions do folks have? What else are people curious about?
So make migrations acts like a version control specifically inside Django and does not
Yeah,
activate or translate until you migrate it.
exactly. Exactly. This is version control for our data model, for our data schema. But this just stays here with these files. Migrate is when Django actually talks to SQL. So make migrations, Django is not talking to SQL exactly like you said, Kenny. Make migrations is just our data model version control. Migrate is when we apply our migrations to our database, is when we talk to Postgres.
And I'm assuming there's a way to migrate, send over the most recent migrate file. But I'm assuming there's a way to kind of send over like the third, second, or even the first one,
Yeah,
right?
you can undo a specific migration, you can roll back, you can apply one. But the nice thing is 99% of the time we won't need to worry about that because Django will do the work of like if all this other stuff has already been done and we have a new migration, Django figures all that out for us. So like if you do so 99% of the time, all we have to do is if I need to change something, like you saw me deleting level, I just need to change my model, make a new migration for it, and apply it. And it doesn't matter if I'm adding stuff to a model or deleting stuff from a model or deleting a model entirely. It's still the same process. Make the migration, apply it. All
So
right.
I had a question
Yep.
for this. So you said with this, we're not supposed to ever directly touch the SQL. And that, I'm assuming, involves creating the schema too.
Correct. This has in
Okay.
fact created that schema for us, right? Because if I do D Pokemon app moves, which is the name of my moves table, I can see that I've got a table which has an ID column and a names character. And Django has taken this model class. The schema is now really the models, right? And
Okay.
Django turns it into migrations and then uses that to make the SQL.
Okay. And then because my personal project is going to have a pretty lengthy database, I just have a ton of classes in the models file, basically.
Exactly. And in
Okay.
fact, what you end up doing is you make a models directory and it's like then each model can get its own file. For today, just for learning, I'm doing it all in one.
Okay. Okay.
Yeah. And in fact, when we have different apps, then each one has its own models directory as your thing gets bigger and you can kind of organize stuff that way. Yeah, great question, Jason. All right. Let me throw the last wrinkle in the mix here, which is exciting, but is also going to be this can be a little bit of a brain twister. So Django gives us something called the Django shell or Django REPL. I can, from here, use my Django code. And what this is most useful for is interacting with our models. Um, there's some fanciness that I'll share probably tomorrow to make this a little easier, but it involves extra setup. So for today, there's going to be some manual steps, but it keeps it simple. And think of this as writing Python code line by line, the same way we would from the Python REPL. So I actually need to import from Pokemon app models, right, from this Python module. I need to import the models I want to use. And now I have my Pokemon model class, and I can use this to interact with the database. And in fact, I can do Pikachu equals Pokemon name Pikachu level 12. Right? And this is an object, the same way we would create a new instance of a class. The interesting part is because we've inherited from this Django model class that uses PsychoPG2 and is the ORM to talk to our database, I can do Pikachu dot save. And this does the same thing as if I had done an insert statement in SQL. And now if I go over here and I do select star from Pokemon app Pokemon, we've got Pikachu, right?
So we don't need migration for that.
Correct.
Oh,
So migration creates the schema the same way with SQL, you might have the one file that makes all the tables. but now we're querying, right? We're inserting data or we can query to get data back. But
Okay.
you are correct, Morty, that if we hadn't applied the migrations, the Pikachu table, the Pokemon table wouldn't exist, right?
Okay. Thanks.
Yeah. And so this is really useful for exploring and experimenting. And in fact, later on, we'll be writing code that does this the same way. And so let's make Charmander, who's going to be another Pokemon. And they'll be a bit behind Pikachu, because Pikachu, I guess, is the favorite at level 9. Now, Charmander's not in the database yet. All I've done is create an object named Charmander, an instance of our Pokemon class. I need to run the save method to save this data to the database. And now we've got Charmander. And if Charmander wants to level up and move ahead of Pikachu, well, that's great. But to persist that data, to save it to the database, once I've modified Charmander, I need to run save. And now Charmander has leveled up.
What if you delete a
Is
column?
I'm sorry?
What if you make a migration that deletes the level column? Will it keep the data?
Good question. If you have data in the database, I believe the migration tool will, the same way where Postgres doesn't let you, delete a table that has a foreign key reference to another by default. The migration tool, I think, keeps you from deleting something where there's data. Don't quote me on that, but I'm pretty sure.
Is there a Django Cascade equivalent
Yeah,
when creating a
absolutely.
class?
Yeah. And in fact, there's even Cascade for relationships. Yeah, everything we've seen with SQL, we're going to be using with models. Great questions.
is there going to be something down the line where after you change, like make a change to the model, it just automatically saves, so you don't have to type it in, or are you going to have to do it every single time?
You're going to have to do it every single time, but since we'll be, instead of using the REPL, writing code, that'll actually be a good thing. We'll talk about this later, but the same way with SQL, you can add all of these constraints, like not null and stuff like that. You can do super fancy validation with Django models, and the save command kicks off a bunch of sort of like automatic, that's how it triggers all of our validation rules. Though we'll see that later. So it's actually a good thing, not a bad thing, though it does add an extra manual step. This is where it can get a little interesting. If I want to query and do excuse me. If I want to query and do a select statement, I have to do it like this, which looks a little different. And this is the other challenge. I'm in P-SQL right now. I recommend using like terminal colors to try to keep track of this stuff, though I still get confused, to be honest. You can also, like, if you have this open a bit more, you can see the names, and that can help. So now let's try Pokemon objects all. So this is not very interesting, right? It's returning an object called query set. There's a lot of layers, as you can see, that we get from Django, but I can see that there's like at least 2 Pokemon in there.
Can you create a repr to make that look more user-friendly?
You can, but what you end up being able to do is you can just sort of manipulate stuff more directly. And Django, in fact, has a lot of tools that we can use to get stuff. Mainly, like, let's just say, let me clear this. The first Pokemon from the results from this query result, I could just do that because it's giving me back a list. And you're absolutely right. We could create a repr. I'm not going to do it now, just in the interest of time, but that would make this a bit more interesting. And we can do first.poke.name, but we can also, and let me just pull up the Django docs, because I always get a little confused with this, and it's a bit easier to just look at the reference. I don't want creating objects or saving objects. I want retrieving objects. And here we go. So this query set object that we can read about in Django, it has this method all, but we can do all sorts of filtering. And this is where stuff gets a bit easier. There's filter. I think there's also, yeah, here we go. Get is sort of our best friend here, because I can do Pokemon objects get ID equals 1. And in fact, let's just do Poke. And so this doesn't return me a query set. It just gets me one thing because this get method is designed for searching for something. ID is kind of useful, but not that great. But you can use it to search for any field. So Pokemon objects.get, and then the field we want to search for is how we would find one thing. I could also do, Pokemon objects filter name. Let's see if I can get this right. Starts with P. And I have a typo here. And there's only one Pokemon who starts with the letter P, which is Pikachu. So filter is a little more complex, but get is way easier and where you want to start.
If you had done that and there were more than one Pokemon with a P, and you said poke.name, would that act like a map in an array and give both names, or would it give you an error?
Oh, well, I did Poke Sub-Zero dot name.
Oh, I didn't see the Sub-Zero.
Yeah, otherwise you're correct. We'd have an issue. Yeah, get is definitely the easier place to start with. I realize I ran a bit long, folks. Today is a bit of a big day. Do folks have any questions before we break? And we can at least get, I think, a little bit of work time in. And yeah, sorry, my power cable was getting a little fiddly there for a second.
So before we do this, should we just deactivate our default environment?
Yes, you should. And in fact, it's not the worst idea today to remove the line from your DSHRC config file that that activates it by default. Sorry, folks, my power cable seems to be fiddling and constantly going in and out. I don't know if you all can tell. I think we're okay. It's making a beeping sound, which hopefully isn't bothering other people nearly as much as it is me. Let me show the assignment, and then we'll break. There's more to cover, but why don't we reconvene at like 11:15 Central so we can get a break and at least like 20 something minutes of hands-on time? Does that sound good? Okay, cool. So we're building this up step by step. Django is going to be a lot, but we're just going to go a piece at a time. And we're going to build one big project over the course of the next 2 weeks. But the key thing is to finish all of the assignments every day. So right now, please get started on this very first school API assignment. All we're doing today is you're going to, for this first part, between now and when we reconvene, get started on making a new Django project, right? There's a test file that we want you to paste in, but the main thing is just creating a Django project and creating a student model. And we've given you some fields to create. So I realize we probably won't be able to get this whole thing done in 30 minutes, but take a break, get off the screen, and at least get a little bit of hands-on time with the code, and then we'll reconvene at 11:15 Central. Sound good? All right, awesome. Thank you, everyone. Let me go ahead and pause the recording. All right, so we've covered a lot of ground. We worked with just a big picture overview of how Django fits into the puzzle, Python virtual environments, and we've created a Django project. And then we have this key workflow of once we've created our project and we've done the modifications we need to the settings PY, I make a Django app that's sort of a container for stuff, right? And in fact, why don't we make a new app? What is it? Start app? Yep. Let's just make a student app. And so now if I want to, have something completely separate from my Pokemon, I can put it in the student app. And I need to remember to add the app to the list of installed apps for Django. We've already configured our database to use Postgres, and we've given it the name of the database. And then we have the workflow of creating models, which then creates migrations, and then we apply those migrations to our database. And for example, I might want to make a student class. Oh, I'm not sure why I got all that crazy autocomplete there. There's actually a couple nice things there that I will keep, but let's get rid of some of the other things. This meta stuff we don't need. That we don't need. Actually, having a dunder str or dunder repr method would be really nice, but it does jump the gun a bit because the student does need a name. And I think I'll give them a first name and a last name. And here, let's actually add some constraints. We'll learn more about constraints later, but let's say null is false and null is false. Our student has to have a first name and a last name. They're going to have an email address as well. And in fact, Django has an email field. So I'm not going to give it a max length. I'm just going to let it be because I'm pretty sure that Django has some good defaults set for its email length, but I will set unique equal to true. And I think for the moment, that's all I'll add for the student so that we can make a migration and apply it to our database. So now that I've created my student model, and by the way, you can, just like with any Python class, add methods to models, and these methods don't impact Postgres at all. It's only when we're using and creating fields and stuff like this. And that's what gets looked at for migrations and applying stuff to the database. And so, in fact, let's go ahead and make some migrations.
You don't have a your repr says self.name, but that's not something that exists because you changed the first last name.
Oh, thank you. Good call, Tim. Actually, let me use that as a teaching moment. Well, I did not do this on purpose. Let's take a look at the migration that's made for our student. And we see here what we've come to expect. We have the fields that we've added: first name, last name, email, right? And Tim, as you pointed out, I goofed here and I did something wrong with the repr. So let's modify it. Let's do an f string and let's have it return self dot first name and then self dot last name. And let's have it also return self dot ID, which Django will create for us. Now, watch what happens when I run make migrations. The message says no changes detected. And indeed, if I look here, this is the same. And if I use git, I would see the same thing. Changing methods does not change our data model, right? So I can change this dunder wrapper method all day long, and we don't need to create new migrations for it. Let me go ahead now and apply the migrations from this student class. And if I hop over here to pSQL and I do a little clearing, if I do /d, we see this long list of tables, but down there is student app underscore student, which is the new table. And we see some useful fields, right? A first name, a last name, and an email. Django has pretty incredible docs. And I do strongly recommend taking some time to read through them. In particular, the field options. There's two big ones, null and something called blank. And let's talk a little bit about the difference between those two. So null does something a little counterintuitive here. If true, Django stores empty values as null. Default is false. And here it says, avoid using null on string-based fields like char field, like I did over here, and text field. If a string-based field has null to true, it means there's two possible values for null data. In most cases, it's redundant. The Django convention is to use the empty string. Basically, if there's no name, I don't want null in the database. I want an empty string. But what we really want here is not the null setting, which, from SQL, we're used to meaning can a value be here. We actually want blank, right? And this is different from null. Blank is database related, or I'm sorry, null is database related. Blank is validation related. If a field has blank true, form validation will allow entry of an empty field. If a field has blank false, the field will be required. Though it does appear that they've added in the database here not null, and this does get, frankly, I get a little confused by this because this form validation stuff is stuff we're not directly using because it goes back to Django templates. We have a sort of a table in a slide deck and in the curriculum that I'll show you all in a moment. But let's add blank false to both of these and see if it changes our data model in Postgres at all. Sorry about that. And now if I do Python manage py make migrations, we actually see no changes detected. And if I run migrate, we actually see no migrations to apply. So blank equals false. We'll see this later when we start writing validation logic, but this doesn't actually affect the data model, which is a little confusing, to be honest. And even these descriptions here, I find a bit confusing. And that's why I do think it's useful to be comfortable looking in pSQL at the data model, because we can very clearly say, regardless of what the docs say, at the end of the day, setting null to false added these not null constraints to first name and last name, which is exactly what we want. And then email setting to unique, obviously, then an email can't be null.
So with the migrations only really they don't happen when you're like if you edit something in an already existing attribute.
No, unfortunately, that's not true. Because if I get rid of this and then we go here, watch what happens. There actually should have been a change from that. Maybe, oh, because it defaults to null equals false. Let's do null equals true. By default, I think a char field is null equals false. And now there is indeed a change. And we see here null set to true. And then if I applied that migration, it would change the data model. And in fact, let's go ahead and do that. And now if I go here to look at my data model, I see that last name can indeed be null, if you'll see where I'm pointing out here. And let's change this back, right? So it turns out that by default for char fields, null is set to false. So I don't need to put that there. Let's see here. It's impossible to change a nullable field last name on students to non-nullable without providing a default. As to someone's point about like what happens if we have real data, this error is actually warning me because if I have real data, this could mess stuff up because it's saying, hey, if you change a nullable field to non-null without a default value, this could mess up existing data. What do you want to do? We actually don't want to provide a default value. We don't have any data in the database, so we can just ignore this. So we're going to just hit 2 to ignore. I'll double check that that's working. And now if I do Python manage py migrate, those migrations should be applied. And if I go over here, we're back to everything being not null. So this is a little weird, but the thing is, blank is a little different and it's not about our Postgres data model. Blank is actually about Django's validation logic for fields, which we will see more tomorrow. So Chase, like if I change max length, if I change null, if I change unique, if I change other stuff, it absolutely will change the data model. But some of these options aren't about the data model. They're actually about validation or other things that we'll see later. Null and blank is a bit of a gotcha, which is why we also have a table for it. This is also in the curriculum repo. Long story short is don't worry about blank so much. Just set null the way you think makes the most sense. But if you run into something where you're not sure, you can take a look at our curriculum and we do have a sort of like helper table to kind of go over this stuff. And I don't want to go through everything, but you can see here, like we go through like all the different fields and we kind of give some advice. With our students and actually with our Pokemon, and I just want to pause and check in if folks have any questions, because I realize that can be a little confusing. Long story short, set null the way you think makes sense, and then if you're not sure, refer to the table. Blank, honestly, I wouldn't worry about so much right now. We probably don't even need it here, if I'm being totally honest. But also, you will want to start spending more time with the Django docs, right? Because as you do this, at a certain point, you'll just need to read about how the docs work and do stuff. And frankly, I need to end up going and looking at the docs often because as things get more complex, it's just hard to keep track of things. I'm not going to go through like all the different fields, but as you can see, Django has a lot of different field types, right? There's Booleans, there's characters, there's dates, date time, decimal, time duration, email, which inherits from char field. We'll learn about Django validators tomorrow. Files for file paths. There's a whole lot more here once we get past file paths. Floating points, IP addresses, JSON. If we need to stick some JSON in there, there's a JSON field. So it's worth skimming through because it's honestly kind of amazing. So this is great, right? I know how to make models. I even know how to use the Django ORM. In fact, now that we have this repr, I could even make a couple students if I want to. I can run the Django shell. I can import from student app models, import student. I can make sure that I've imported the student class. I can create a student. And Tim, like you were saying before, I can use the dunder repr method so that I can get nicer information printed out about the instance of my student class. I can save my student to the database. And then I can get all of my students back. And I get, again, with that nice dunder repr method, some better printed information.
Your student ID from your repr method is returning none.
Uh,
I thought they were supposed to auto increment.
where is it returning none?
You created student Alice equals student, and then you went to see Alice, and your repr
Oh,
method returned none.
excellent point. Actually, so check this out. Very good point. So if we look over here, Alice is none. Look what happens after I save Alice to the database and we get the query set back.
I see that.
Yeah. So what is it? Student objects get email equals alice@gmail.com. Let's see if I got this right. There we go. So 3 guesses. Why was it none before the ID, but it's 1 now?
Because it wasn't actually in the database until you did the save, and
Yeah.
then it assigned its actual
Exactly.
want to call it an index, but an ID number.
Exactly. And this is yeah, that's an excellent point, Tim. And actually, this is great to point out. So we created our object, our model object. And this is where ORMs can get a little tricky, but the ID gets generated by Postgres. So the ID doesn't exist yet. So it's actually none right now. And then when I save Alice to the database, that's when the data, we actually do an SQL insert statement, and Alice's ID is created and she's saved to the database. Yeah, great question. And I know it can feel a bit tricky, but the more you kind of start experimenting and practicing with this to feel comfortable with what is Postgres doing and what is our Django Python code doing, the easier this will become over time, I promise. So this is great, but what if, I need to drop the database or I do something silly and I drop it by mistake? Well, it's not letting me because I'm in here. So let's connect to a different database. Let's see if this command runs now. Yeah, there's one other session using the database. Let's just delete it from here. Drop database, Pokédex DB, error syntax. That doesn't seem right. There we go. So my Pokédex database is deleted. Unfortunately, I've lost all that really nice data that I added. It would be really nice if I had a way to insert some fake data into my database consistently. And thankfully, Django has a tool for this called fixtures. So it's really nice to have sample data or fake data or what's called mock data. One tool to do this is what Django calls a fixture. And we can do this by basically putting our fake data in JSON and sticking it in a file, and Django will load it into the database for us. So let me show you all how to do this, and we'll start with I think the Pokemon, and then we'll do the students. So there are a couple steps here. Inside the app, I need to make a directory, and the directory has to be named fixtures. And then inside that directory, I need to make a JSON file. And right now, there's nothing in here. And I'm just going to copy and paste this in, and we'll talk about it. I think I'll add Charmander too. And our JSON data here really has to follow a pretty strict format. It's an array of objects. The object has to have certain properties. It has to have a key named model, and this then has to be the name of our Django app and the name of the model. It has to have a primary key field, and one of the tricky things about fixtures is we have to manually set the primary keys. We have to have a fields property that has to be an object, and then for each of our fields, we just go ahead and we add the appropriate field. And let me do a little split here real quick. I think this is a good way to look at it is, let's go to Pokemon data JSON, and let's go here to the Pokemon models. So our Pokemon model has a name and a level, and each of those goes in this fields object. And when I want to add more data, I need to follow the same format. So let's add Charmander. And the primary key now needs to be 2. And this is the annoying part about fixtures. There is another way to do it that's a bit more advanced, but it's a bit more out of scope. And Charmander leveled up earlier, so we'll give him level 13. So the JSON can be persnickety. That's, I think, by far the most common error when creating fixtures. But the nice thing is once this is done, I can now load this into my database. So once the fixture is created, I'm going to, in fact, pull this out so we can see the load data command because I always forget this. We can run Python manage py load data Pokemon data. So I am going to recreate my database. And I'm going to fix the typo. So I'm telling pSQL to create this database again. And if I could spell create DB right, it would. And now in here, I should be able to connect to Pokédex DB, but there's no tables because I need to apply all of my migrations. I'm going to run make migrations just to make sure there's not anything I missed. Can't open file manage py no such file in directory because I'm in the wrong directory. I need to be in my project root where the readme and manage py is. So let's run that again. No changes. Let's apply all of those migrations, all the Django stuff, and all of our model stuff. And lo and behold, boom, we get our whole database spun back up. And now let's load our fixtures. And this load data command is a little weird. I believe all I do is I give it the file name because the manage py will look inside the fixture directory for all the apps to find the file with this name, which can be, frankly, I find kind of counterintuitive, but that's just how Django is. And now if I do select star from Pokemon app Pokemon, we've got our two Pokemon in there. And in fact, let me open up another directory and make sure my virtual environment is activated. And let's run the shell. And let's import the Pokemon model. And in fact, it would be nice if we added a dunder repr method here as well. And let's do the same thing of self.id, self.name, and self.level. And let's do Pokemon objects all. Now, something interesting happened here. I can see that I've got my Pokemon, but that dunder repr method is not working. This is one of the annoying things about the Django shell. Because I changed this code after starting the shell, we don't get that most recent change. And now I have to restart the shell, but I get the change to my code. So that's a bit of a gotcha, right? Where you can kind of go a little nuts trying to figure out why I'm not seeing my code changes. There is something called, I think, like IPython that makes this a bit easier, but it also involves more setup. So I'll share that link later for people who are interested. But now we have fixtures, which is awesome because now I can have fake data and now my coding workflow is great. I need to drop the database, no sweat. I can recreate the whole thing in a snap and add fake data. So that's the big thing really to cover for the second part of this lecture. If folks want to, we absolutely can add more fields to our Pokemon model and play around with it. I think, in fact, I'll show, well, there is one more thing to show actually, which is adding class methods. But before we dive into this, I want to check in and see what questions folks have about fixtures. because I think I covered a lot of ground there. So what's on people's minds? What might be good to see or go over again with regards to fixtures?
That directory fixtures has to be called fixtures, and then
Correct.
whatever, and then the specific naming criteria for the actual JSONs.
Exactly. And in fact, let's make some fixtures for our students as well. And I'll be a bit lazy and do this with the GUI. I'm going to make a directory named fixtures under student app. And in here, I'm just going to make a file and we'll call it student data. You can name it whatever you want. It's just easier to name it the same as the model. Here's how I recommend making fixture files. Find some other fixture file, copy and paste it. Get yourself some screen real estate. Do a split. Put the model on one side, the fixture file on the other, and then change as needed. And let's get rid of this one because this, I don't want to have to copy around two things. I've got a student. I need fields. I need first name, Alice. Last name, Waters. And then email alice@gmail.com. The biggest gotcha with JSON is trailing commas. It doesn't like it. It will actually break the JSON. That's by far the most common JSON error. And now let's add in another student. And while I'm doing this, what questions around fixtures do people have?
Can you explain like what a fixture is exactly again?
Yeah, it's fake data that we will put into the database, and Django will do that work for us. So instead of having to like manually add data to the database, so I can, because if I'm writing code and adding features, it's really nice to have some data in my database to say, test my queries. I can just have some fake data here, and then Django will load this for us. And the reason this is nice is because as your apps get more complex, sometimes you will need to just delete and rebuild the database. Or you might need to delete a table, right? And having these fixtures means that rather than having to like manually do a bunch of SQL insert statements or through the Django shell manually create, students and do student.save, I can run one command to load all my fake data. Does that help break it down a bit, Chase?
Yeah, so it's like sample data, so that way you don't have to like
Exactly.
create more or whatever. Okay.
Exactly. But what you'll find out once you all start working on more Django stuff and your full stack projects is that sample data is incredibly powerful and one of the most useful things to have. So you'll end up with lots of stuff in here. And so now I
I
can run this command to load my student data. Yes.
So with primary keys, do they have to be an integer using the fixture, or can you use strings? Because I find I like using strings more for my primary keys.
They have to be an integer. Long story
Oh, okay.
short. I would also
Okay.
recommend avoiding strings for primary keys.
Okay.
Most of the time, you do not want that. Whatever that string value is probably belongs in some other field. By default, note how with the model, we don't add a primary key or an ID field. By default, Django creates an auto incrementing primary key that's an integer and the column name is ID. You can modify that if you want, but I don't recommend it. Yeah, if you want to, we can look at your data model if there's something you've been putting in as primary keys and talk about what the better pattern is. Yeah, good question. And note that it's a little weird because primary key, it's not in here as like an ID field, right? We're not doing this. We have to treat it kind of special. And that's because Django handles the primary key generation process. And now if I go to Postgres and I do select star from student app students, interesting that there's only one.
You have the same primary key for both of them.
Yeah, that's a good one. Easy mistake to make, right? And we can in fact see what happened there. Bob just overrode Alice. So let's just load that data in again. And now we've got Alice and Bob. And if I here in the Django shell do from students app models import students, and I do student objects all, I get all the students from my database. All right, let's look at one last thing and then we will be able to call it a day. And this is adding class methods to our models. And we are going to do this with our Pokemon model as it shows in the example here. So let me just close these other things out and pull up the Pokemon, and then we will dive on in. Oh, there is, if there is time, there is one more thing I'd like to show folks with the Django admin site. So we might run just a couple minutes long, but not too long. We've already seen a class method on our model with this Dunder's repr method. But we can actually write methods that interact with our data. Now, oh, I'm so sorry, folks. There we go. Now I can write this method, and let me go ahead and let me quit the Django shell and let me reopen it. And let's say I had, let me go ahead and do from Pokemon app models import Pokemon. And let's do, Pikachu is going to be Pokemon objects get ID equals 1. I've got Pika. I want to do Pika level up. Now Pikachu's at level 13. But if I go into Postgres, that change hasn't persisted, right? So what do I have to do to save the change in Pikachu's level to the database?
You just save it.
Yeah.
So you didn't include it in the method.
Yeah, exactly. Thank you, Tim. So in here, I can do self.save. Now, annoyingly, because of the limitations of Django shell, I have to restart it so that we'll get the new behavior of the method, but we can do this relatively quickly. Pika's at level 13. And if I go into Postgres to check out how Pikachu's doing, they've also leveled up to level 13. Right? So this is a great example of how models are cool because we can make all sorts of changes to our Pokemon. Like say, if a Pokemon is caught, we could have a Boolean field with a default value of false. And we can do change plot status. Or in fact, instead of is quat, let's just change this to captured, because that's shorter and takes less to type. And we can flip the value. So capture or uncapture. And we can do it by doing self.captured equals the opposite of whatever it currently is, and saving it to the database. If I wanted to get fancy, I could even maybe give an optional argument that we pass in, though I think that might get a little tricky. Probably the easiest way to do it, to be honest, is like making a capture or an uncapture method, but we could pass in Boolean values here as well, is the point. Like if for some reason, if I wanted to, I could do self.captured equals captured. So I could call this method and capture or uncapture my Pokemon. I'm not going to run it now because I don't want to go through the whole flow of having to stop and restart. Though actually we can show this because this is actually relatively fast. So I've got to make a new migration. That adds the captured field. I've got to apply the migration. And then over here, let's quit this shell. Let's start it up again. We have to go through this little dance. We're not printing out Pikachu's captured status in the Dunder repr, so let me just print it out here manually. And it's false. Let's go ahead and do pika.change plot status. And let's set it to true. And it would help if I spelled that correctly. So let me just fix my typo. One positional argument, but two were given. I wonder what I did wrong here, because that sure seems right. Oh, I have not saved this file. So I apologize. I don't want to go through the whole flow of having to stop and restart this to show this. But we can see that, well, let's do this one more time. We'll get our Pokemon. Let's do Pika change bot status true. And if I go into PSQL, we see Charmander is not caught, but Pikachu is. So we'll see how to build this up, but this is why Django models are sort of the foundation of our whole Django app. because of all the different things that we can do with them and how we can have we can write methods that like interact with our data. I know there was a twist and turn there along the way, so I just want to check in and see what questions people have. How are we feeling about this idea of adding methods onto our models that get to interact with our data?
I think I mean, it's like the OOP assessment we did. But I think for me, this whole thing is kind of confusing so far, but it makes sense, like, like on what it's doing exactly.
Got it. Yeah. And the main thing to remember here is I've got a model over here, and this is OOP land, right? So just like how sort of sorry. Here in the world of the Django shell, I've got an object. We're in OOP world, and I can do whatever I want to this object. And what Django ORM, what models do is they let us take stuff from OOP world and move it into Postgres data world. Because I've changed the property of this object, that I've changed Pikachu's name, that doesn't mean that change has been sent to the database, right? That's what that .save method does. So this is how I can write OOP Python code that can save data to Postgres. And now Pikachu is no longer Pikachu. And I can use OOP code to get data from Postgres. And so just like any other Python class, I can have methods, but because we're using this special model class whose job it is really to talk to Postgres, we get to do all this extra stuff along the way. And so to kind of build this diagram out a bit more, if that's the model class, then our Pokemon model has inherited from it, right? And the Pokemon model here, and we'll make a nicer arrow. It's a semi-terrible arrow, but not the worst. And in fact, we'll name this Pokemon app Pokemon. And let's give ourselves a little more room here. And let's draw another box. And let's take one more stab at making a decent arrow. So we've got a Pokemon model, and it's normal Python, and I can do all the nice OOP stuff. But because we're inheriting from this model class, I can also talk to the Postgres database. And Django Models does the work of saying, all right, I've got this OOP stuff. How do I translate it to a table, to columns, to rows? And so we can have all of these methods, but then when I hit save, we're using Django Models to save this data for this object into our table. And we get to map an object to a table and vice versa. I don't know if that helps kind of lay out the different pieces a bit more. But I just wanted to build out that diagram a little bit. Does that help a little bit, at least kind of break down how the pieces interact?
Yeah, no, it does.
Yeah. And by far, as with all things, practice is the way to go here. Along the way, you all will find that you'll sort of be refreshing your OOP knowledge and deepening it, right? Because we learned about object-oriented programming, weeks and weeks ago, but now we're using a framework that is all OOP all the time, right? Like what's happening here is I've got a class attribute, but right here, we're creating an instance of the char field class. And so each of these attributes like holds its own char field object. That's an instance of these different classes. So we've like really leveled up in OOP because we're using it for everything. So you may want to do some diagramming and digging through stuff and reading of docs to help get comfortable with things. As weird as it can feel, I think also the Django shell is incredibly useful because it forces you to think about that this is an object. But my object also has, and I can change properties on my object. But my object also has properties that let me save its data to Postgres. So there is one more thing I want to show folks, and I know we've ran a bit long. So I'll kind of move through this one a bit quicker and then we will wrap up. And what I want to show folks is Django admin, because it is a useful tool and it will help make some of this more concrete. Django has a great tool for us to manage the data in our database. We do have to make a couple changes to make it work. And I'm going to show this just with our Pokemon. So in the Pokemon app, I do need to go into this admin py file. And I do need to import from the models module in this app, our Pokemon model. And then I do need to register with the Django admin site this model. And in just a moment, we'll see what this does. I also need to create a super user, like a super admin, like a root user. It's going to prompt me for a username, an email, a password, which I recommend just making password because you don't need it to be safe. And now what I can do is I can run my Django server. And go to this URL over here. And I should be able to do /admin. And I need my username and my password. But I can now log in. We will learn about authentication and users and groups later. But if I look here, lo and behold, I have the data in my database. I can actually change it. And this persists to Postgres and everywhere else. And in fact, it's a little hard to see, but you can see all of those HTTP GET requests. Here's a post request, right? When I changed that data. And in fact, I could let's just open up the network tab real quick and watch this as we do it. And let's in fact add a new Pokemon. Let's not worry about all that stuff now, but what is it? Eevee, like level 14 and Eevee's captured. Let's go ahead and clear this and let's watch what happens when I hit save. So there's a lot of junk in here. I'm actually not sure if I can find the post request. Because there's all this JavaScript stuff going on. So unfortunately, I think I wanted to be able to show us, there we go. That was a get. Here's our post. So this is the post that creates EV. It's a little hard to see because it's using an HTML form, but we can see this 302 response. And what we see over here with Django server running is every single HTTP request that the Django server gets. And as you can see, this is a lot of stuff for JavaScript and image assets and all this stuff that make up the UI on the page. But right here is the HTTP post request to add EV to our database. And if I hop over here to pSQL, we've got EV. So Django admin is super cool, and I think it can be a really nice tool for interacting with your data. And just to recap how to set it up, let's do this for students as well. First thing I have to do is for the model that I want to add, I need to go to admin.py in the app. I need to import the model. Then I need to do admin site register the name of the model and save it. And then if I haven't already, I need to create a super user. But once you've created a super user, you only need to do that once. So now I should be able to go back here, and under the student app, we also have our students. And that is Django admin, which is why Django is kind of cool. So I know
admin just kind of creates a GUI.
Exactly. It creates a GUI, and it lets us interact with Postgres, and it will do like validation and all the stuff. And as the name implies, it's really meant for administrators. Like you don't use this for user-facing stuff. This is more of a utility tool for us. Like if, for example, we really were making, like a sort of learning management system for students and grades and courses, maybe with Django admin, this is nice because out of the box, me as a teacher or an administrator, I can, add a student to a course or whatever I have to. And since this create, read, update, delete, these CRUD operations are so common, Django admin just gives us that for the database out of the box. And do folks have any questions around Django admin? Okay.
So like if we're developing this for like some company and we want like the IT department to be able to do stuff like this, we would like give them like power to do this, like create them as a user.
Yeah, exactly. You just need to create like a super user admin account, and then you would create probably like an account per IT person. You can also control the level of permissions for admin accounts, but that gets more complicated. Yeah, so it's incredibly flexible. And there's tons of stuff with permissions control and things that we haven't gone into that we'll see a little bit of later. But we will only really scratch the surface with Django. Because again, Django is like, if you want to build a skyscraper, Django is the crane and the bulldozer and like all the tools you need to build the skyscraper. So we're not going to go into like every dirty detail, but we're going to show the most important pieces so you know how to build like the skeleton. And then whether you have like revolving doors or like doors that open and close, that sort of you all will be able to figure out on your own. All right. Let me go ahead and stop our recording, and then we'll just quickly talk about homework in the rest of the day, and I'll stick around for anyone who has questions.